Hello everyone and welcome to the measures of variation or measures of spread. In this section or in this short meeting we are going to discuss some basic measures of spread or variation. The measures of variation describe how spread out the value are and why the variation or spread matters. For example, we may have two different data sets. Those data sets have the same mean, however, the spread is different, right? Also, variation helps us to see how consistent are our data and how much do values differ from the center. All right, so let's talk in more details in the next slides. So the common measures of variation are range, variance, standard deviation, and IQR. In this video, we are going to discuss the first three, range, variance, and the standard deviation. And we are going to discuss the IQR, the fourth measure of variation, in the next section because it's a very long definition, and I have to introduce some other definitions before IQR, such as Q1, Q2. Also, we are going to discuss the box plot, so it has like a different video. All right, so let's start with the first measure of variation, which is the range. The range is the difference between the maximum and the minimum value, or you can say the range equals max minus min. This is the range. So it's the difference between the largest data point and the smallest data point. So we only use two values. This is one of the limitations. And the range is very sensitive to outliers because it's the maximum minus minimum, right? So if we have like some numbers that are close to each other and then we have a very large number, then in this case we have outliers and the range is very sensitive to outlier. Okay, the second measure of variation is the variance. And the variance measure the average square deviation from the mean. So if you look at the formula here, the sample variance or S square is given by summation xi minus x bar squared divided by n minus 1. X bar is the sample mean. So we are trying to find the distance between each observation and the sample mean. For example, suppose we have x1, x2, x3, and x4 is here. And our sample mean or x bar is here. So the idea here is we have to find the distance between each xi, for example, x1 and x bar, and the distance between x2 and x bar, the distance between x3 and x bar, and the distance between x4 and x bar. All right, so instead of dealing with maximum and minimum, like the range, we deal with the difference between each point and the center of the data. Okay? One notation about the variance is the variance is always positive because if you look at the formula, it's the summation of xi minus x bar squared. So we have to square the distance because this distance could be positive or negative, right? So we have to square the distance between xi and x bar. So the variance is always positive. It could be 0. So to be more accurate, we can say that the variance is greater than or equal 0. The variance is 0 if we have the same numbers like 5, 5, 5, 5. In this case, x bar is 5, so xi minus x bar is 5, right? So the variance is always positive. So large variance means we have more spread. Standard deviation is the square root of the variance. So for example, if our variance is 16, then the standard deviation is the square root of 16, which is 4. The good thing about the standard deviation, it's easier for interpretation comparing to the variance because it measures the spread in the same unit as the data. For the variance, it's the square of that unit. So sometimes the variance is a little bit harder for interpretation, but the standard deviation is easier for interpretation. Again, large standard deviation means more spread. Small standard deviation means less spread. When the standard deviation is 0, this means there is no spread. Example, find the sample standard deviation. All right, so we have the numbers 2, 4, and 6. So the formula is listed in the previous slides, right? So first of all, we have to find the mean, or x bar, or the sample mean is summation xi divided by n. So we only have 3 numbers. So 2 plus 4 plus 6 divided by 3. 12 divided by 3 is 4. So x bar is 4. Then the standard deviation or S, it's the square root of the variance. So it's the square root of summation xi minus x bar square divided by n minus 1. Right? Which means n is 3, so we have to divide by 3 minus 1, or 2. xi minus x bar, xi are 2, 4, and 6. So from each number, I have to subtract x bar, which is 2. So the first xi is 2 minus x bar, which is 4. This is x bar. So 2 minus 4 squared plus the second value, or the second xi is 4. So 4 minus 4, so you can just write 0. And the third xi is 6. So 6 minus 4 squared. All right, so square root of 2 minus 4 is negative 2 squared is 4. 0 squared is 0. And 6 minus 4 is 2 squared is 4 divided by 2, which is 4 plus 4, 8. 8 divided by 2 is 4, square root of 4, which is 2. So the standard deviation, or the sample standard deviation, is 2. This means, on average, the data values are 2 units away from the mean, right? Because this is the meaning of standard deviation. So on average, the data values are 2 units away from the mean. Actually, there is an equivalent formula of the variance, or the standard deviation. So let me introduce that formula here. So the variance, or S square, this is another way to find the standard deviation or the variance. The formula says, so let me write the formula here so we can use it directly. The formula says S square, or the variance, equals summation xi square minus summation xi, everything square, over n, and we divide the entire fraction by n minus 1. So this is another way to find the variance. So if you use this formula, xi are 2, 4, and 6. So maybe I can create like a short table here, xi, and this is xi square. The values of xi are 2, 4, and 6. And xi square are the square of that. So 2 square is 4. 4 square is 16. 6 squared is 36. Then we create the sum of each column. The sum of this column is 12, and the sum of the second column is 30, 40, 56. Okay? Now, this notation here is summation xi, right? Because this is the xi column, and we are calculating the sum of that column. So 12 is summation xi. Similarly, this notation here is summation xi square, because our column is xi square. Okay, now you can plug in the numbers in the formula. So S square, or the variance, equals summation xi square, which means 56, minus summation xi is 12, but we have to square it. Summation xi is 12, so 12 square divided by n is 3, and we divide the entire fraction by n minus 1, which is 2. Okay, so this is 56 minus 144 divided by 3 is 48, divided by 2. So 8 divided by 2 is 4. So the variance is 4. If you take the square root of the variance, then we have the standard deviation. So S squared is 4, so S equals square root of 4, which is 2. So this is an alternative way to find the variance or the standard deviation. I recommend using this method because especially if your xi, if the sample mean is not an integer. So for example, here in this example, our x bar is 4. It's easy or very easy to calculate xi minus x bar and then square it. But suppose your x bar is like 4.17. So here you have to say 2 minus 4.17, and then you have to square it. So you have to use your calculator sometimes to square that number. So it takes like more time. However, if you use this idea here, in this case, if you have integers, you don't deal with decimals, just xi and xi square, and plug in the numbers directly in the equation. So you don't have to calculate the difference, I mean the square of the difference between xi and x bar. Anyway, those are two ways to find the variance and the standard deviation. You can use any of them. I prefer using the second formula. It's up to you. You can use the first or second. But at the end of the day, we have the same solution. All right, thank you. Thank you very much. We are going to discuss the IQR in the next section. Thanks for watching.